Yeah, right now, right? Mr. G Math Live, right? Say hi to YouTube. Yay. All right. Oh, dear. All right, here we go. So, I want to estimate the integration, which is another way of saying area under the curve. In this example, I wouldn't have to estimate. I could actually integrate and do the fundamental rule of calculus here. But instead, I'm going to practice using rectangles and trapezoids. When you use rectangles to estimate the area under the curve, it's called a Riemann sum. So we're going to start first with midpoint. It first says that they are equal size in terms of the width. So I'm going to split this into how many different? 1, 2, 3, right? So I'm going to create some space here. So each one is going to be different. So the first one is going to be midpoint, okay? What's the first thing I need to do? Do you know? First thing you need to do is find the common width. Do you know what the common width is? How to find it? As I said, do you know how to find it? So subtract the limits, and then divide by how many we have, which is 3. So 6 divided by 3, the common width is 2. So that's where I'm going to start. Next, I'm going to do midpoint, right? And so this starts at 3 and then goes to 9. It might be helpful to at least think through it. If they're all a width of 2, the first rectangle goes from 3 to what number? If they have a width of 2, the first rectangle starts at 3 and goes to, so that means the midpoint would be what x value? Most of you need to remember that if it's free response, to let it go. That you have to know how to substitute in and not try to brag that you can simplify it. Because so many of you make mistakes when you simplify. If you had to simplify it, if it was multiple choice, then that's what you do, right? Plus, what's going to be the next midpoint? So the next one goes from 5 to 7, so the midpoint would be at 6. And then the last midpoint x value would be at 8. That's it. That answer would be an estimate, right? Using a Riemann sum, midpoint. I want you to do the same work, but this time it's not midpoint, it's right Riemann sum. And then how would that change? What would stay the same? And then how would it change? And it's good practice just to substitute in and not simplify. And likely, if you had to simplify it, it would probably be a calculator question where you'd be typing it into a calculator anyways. Just take your time. Did you set it up for a right one? Which one stays the same? What changes? So what's going to stay the same is 2. For a right Riemann sum, again, we need to know the intervals of each rectangle, correct? So the first rectangle goes from what x coordinate to what x coordinate? 3 to 5. So a right Riemann sum, which x value would I use? And the answer is the right value, which is 5. That was a pun, right? The right value. Play on words, as they say. So the next interval, what would be the correct right value? It goes from 5 to, so it would be what? 7. And then lastly, what would be the correct right value to end it? Would be 9. Good. And again, I know it's tempting, but do not simplify it unless you have to. Be comfortable knowing how to substitute in with parentheses, and then just let it go. Okay, the last one says use what? Remember, that's the Gertz sum. So think, what's going to be the same? What's going to be different when we use trapezoids? First of all, I need to recognize the formula for a trapezoid is different than a rectangle. So the formula for a trapezoid starts with what number? Then what's the common width of each trapezoid? 2. That stayed the same, didn't it? Then for a trapezoid, right, what am I going to have to do? I need to do each one, right, in terms of the interval. Now we have 3 trapezoids, right? So what's the first x value I would use? So I'm going to use 3. Notice I don't double that answer. That 2 is in front of everything, right? That's the common width. But the first height, I just write down once. Why is that? Because the first height of the first trapezoid is not shared, right? It's just that one trapezoid. Now we have to remember to do what to the heights as we move along? To double it. So when I add, I'm going to start with 2. And then which number am I going to plug in next? 5. Then which number am I going to plug in next? Again, I'm going to double it. 7. And then lastly, right, the last one, which is 9, what am I going to do? I got too many parentheses there. All right, and then close it, right? So, do you understand the structure of a Riemann sum and the structure of a trapezoidal sum? Why do we have a Riemann sum and a trapezoidal sum? Where do we use it? Why do we use it? And so it has to do with estimating integration, right? Many times you're not given an equation or given something where you could find the exact value of it, but instead you have to have a tool to estimate it, right? And so one of the tools we use are rectangles or trapezoids. All right, number 2. You read it. He said it's okay if we take our time, right? We're not like going to be thoroughbreds here. More like a donkey walk, on a racetrack. Is that okay to be the donkey on the racetrack?
We're live, Mr. Griffin.
We are live. Is it okay to be the donkey on the racetrack? I don't think that's bad to say live. Hey, do you know how to find the area bounded by 2 equations? What should I do first? There are 2 things in my mind, right, that I need to do. One thing is, I need to know what the bounds are. Do I know them yet? The second thing I'm thinking of, I need to sketch to get a picture because I need to know what equation's on top and what equation's on the bottom. So both I need. It's probably more helpful to find the points of intersection because then you can put them on your graph and you already have a starting, right, for the graph. How do I figure out where they intersect? Let's do that. That is on live, right? The person that's worried about it being live, yes. It's okay. YouTube will now restrict the video because he said that word. No, I don't know how they do that because apparently I forget how many hundreds of thousands of videos are uploaded like daily. There's no way they can. I don't know how they do it. Yeah, is that what it is? Big Brother, right? Always watching. So how do I solve this? Have you heard that concept, Big Brother always watching? Like the idea of cameras and everything everywhere, right? Watching everything, listening to everything. Okay, it's a quadratic, so I'm going to make it equal to 0. So I'm going to add 2x. I'm also going to subtract 4 to both sides. So I can see the 2x's will eliminate. On the left side, I have x squared and subtract 4. They're unlike. They go beside each other. Can you solve that for me? You should be able to do this in your head, actually. What number squared take away 4 is equal to 0, right? You can factor it, difference of squares. But the two answers are positive and negative 2. Correct? So now that I know the x values, what do I need to find next? Yeah, like there's no point of having just these x's are important because now I know my bounds, don't I? So when I set up the integration, they're going to go from what number to what number? From negative 2 to positive 2. So they're important. But for graphing, I need the full point. Does it matter which one I plug it into? So I'll use the line. Negative 2 times 2 is negative 4, plus 4 is negative times a negative is positive 4, plus 4, which is, so I have 2 points here. One point is at 2, 0, and the other is at negative 2 and 8. I am now going to sketch it. And a sketch is a sketch. Ultimately, what I care most about with the sketch is to understand which equation's above the other one. Correct? So if I had 2 points, I know my line. This is a parabola. So what don't I know that I need to know still? Is the vertex of the parabola. It's good practice to remind yourself what that formula is, which is negative b over 2a. So in this case, the b is negative 2 and the a is positive 1. So when I simplify it, at what x coordinate is the vertex? At positive 1. And then how do I find the y coordinate? Plug it back into the parabola. You don't have a choice. And when you do that, the answer is negative 1. All right, now do you see your parabola? I am going to shade in the area that is bounded by those two things, right? The boundaries. So that's the area you are finding. Now you are ready to do the calculus. What's the calculus that allows me to find the area trapped between two equations? This is an integration question. What are the bounds? From negative 2 to positive 2. Then what do I set up? Which equation is above the other one? So negative 2x plus 4. And then what do? Subtract. It's top, subtract, bottom. And the bottom is x squared minus 2x. And that's dx. Simplify this. So I'm going to subtract x squared. I'm going to put them in order. So I'm going to subtract x squared. There's no other x squared terms. Negative 2x, subtract negative 2x. They eliminate, right? Negative 2x, subtract negative 2x. And then what am I left with? 4 take away nothing. So it's just 4. The question says not just set it up, but to find the area. So what do I do next to find the area? Integrate it. This is not a fancy rule in calculus, just the anti-power rule. That would be what? What do I do with the exponent? Which would become? And then what? And then how about the 4? What does that integrate to become? 4x. And I'm integrating from? Negative 2 to positive 2. All right. Give me the answer. You do not need to simplify the answer. Just give me the answer. How do I go? What's the next step? What do I plug in first? So I plug in 2. And then I subtract. And then what do I plug in? Notice for a positive number, the parentheses aren't necessary, but for a negative one, they are. Oh, is it off the screen?
Whoa.
Fair enough. The projector and my computer screen aren't exactly mirroring each other right now. So again, we're taking our time, so it's going to be a longer video. If I just said, think, what are the steps to find the area between two curves? Did you see the steps I did? I found the points of intersection. That also gave me the bounds. I graphed it. And then when I set it up, I used the bounds. And I remember it's top, subtract, bottom. I simplified it. I integrated. And then again, I plugged in the top bound, subtract, plugging in the bottom bound, and didn't simplify it at the end. When you're ready, read question number 3. So again, when you're ready, read question number 3. It says, take the area from question number 2, see the area we found, and find the volume formed by using square cross-sections perpendicular to the x-axis. Then it says now use semicircles and now use equilateral triangles. Now the good news is, because of the work we did in number 2, now it's really simple to be able to do what we're doing. So after we simplified, this is what we did for the setup for the area. -2 to +2. And it was negative x squared plus 4 dx. That gave you the what? The area. Now, how do I find the volume? And we're going to have different ways to do this. So one is squares. So what is it going to look like for squares? Well, we're still going to integrate from -2 to +2. What's going to describe the side length is exactly what we did to find the area. Now, the formula for a square is one side, and what do you do with it? Square it. And then what describes one side length, if I connect from top to bottom, is that negative x squared plus 4. So if you need to remind yourself that one side, this is what it's equal to when you go top, subtract, bottom. We already did that work. Now we're just using the work we did. This describes squares. Now, can you take your calculator now and then tell me what the volume is? Use your calculator and tell me the volume using square cross sections.
Although I took yours.
Yeah, I'll do it.
I thought that was not yours.
You want it exactly?
That was yours.
What happened? If it's an exact fraction, I want that. So, now that you have your calculator, do you remember what button to press to find the integration? So beside the 9, press that button, go to the integration template, and we're going to integrate from -2 to +2. We're going to have parentheses. We're going to type in negative x squared plus 4, and then we're going to square it, and then we're integrating with respect to x. So the exact answer is always better than a rounded decimal. So the exact answer is 512 divided by 15. If I did the decimal, I don't like that as much to round it. So I'm going to write down 512 over 15. All right, now, we just use squares. Could you do the same work and now use semicircles? What's going to be the same using semicircles? The bounds. We're bounding right from negative 2 to positive 2. Do you remember the formula for a semicircle? 1/2 pi r squared dx. Now, this side represents the diameter of that semicircle. So when I substitute in, I need the radius. So what am I going to do to that side to get the radius? Divide it by 2. Use your calculator. Yes. You can put the pi in front or keep it inside. They are equivalent. Usually when we're doing rotations around an axis, we do the template where the pi is outside. But it could also be written inside. For this, for a cross-section, usually we just wrote it that way. But if you put 1/2 pi in front, you would get the same answer. All right, let's see if we can type it in. Instead of 1/2 pi, I'm just going to write down pi over 2. I'm going to type in any questions as I'm knowing how to type it in. So, can you see what I'm typing in? So, pi over 2. Negative x squared plus 4 over 2, all squared. This will not give you a nice fraction, so might as well write it as a decimal. And the rule is 3 decimal places, and you can truncate it. So that means this is the exact answer, 512 over 15. The approximate answer for semicircles is 13.404. All right, last one is to use equilateral triangles. Did you get 13.404? Are you practicing? Do you want to see what it looks like again in the calculator? You can go 1/2 times pi. That because you didn't type it in right. So it should give you the same answer. But 1/2 times pi means the same as pi over 2. If you can be efficient and accurate, that's a good combination, right? Efficient and accurate, that's pretty good, right? That's what we're trying to do. Okay, as you're waiting, equilateral triangles. What's going to be the same if you use equilateral triangles to make your volume? And what's going to change? So I'm going to move forward here. Remember, if you need to, you can even come in at lunch or whatever, right? Practice with your calculator at home too. So we're integrating from negative 2 to positive 2. The formula for an equilateral triangle is, and then we square the side, right? Now for this one, we need the full side. So we put in negative x squared plus 4. Now use your calculator. So I'm going to type it in, then I'll show you what it looks like after I type it in. Square root is with the x squared. You got to press the blue button first. So I get approximately 14.780. This is what it would look like on my calculator. Can you see it on the screen there? So, practice knowing how to type it in. I know it's a skill. Don't take it for granted to know how to type it in using the calculator correctly. But did you get 14.780? When you're ready, turn the page. Did you get it, Lala?
Yeah.
Good job. Okay, turn the page when you're ready. All right, first you. You read number 4, please. And then I'll help you solve it. So for this question, I might go back and forth on the page to go back to the graph to get a visual of it, and then come back to number 4. So you're still taking the area that you found in question number 2, but now how do you finding the volume is by revolving it around a line. So in this case, first the x-axis, then y equals 10, and then y equals -5. So let's start with the first one, the x-axis. Are we ready? Can we go back to the front page? If I revolve that area around the x-axis, right? Does that whole area hug the x-axis all the way through? Or will there be a little hole in it? Well, I have to do 2 circles. Can you see that if you revolve around here, this area, that there is going to be a bit of a gap here? Do you see that? Right here? That it hugs up to a point, but then there's a gap, isn't there? So I'm going to need to have 2 circles. You ready? How do I do that when there's a hole in it like that? What do I do? So it's going to be a washer, right? So we're going to still go top, subtract bottom. So with the x-axis, what's going to be the big radius and what's going to be the smaller radius as we go along here? So as we do the radius that we're revolving around, we're still going to go top, subtract, bottom as we revolve it around. It's a little bit more challenging because we have an area that's above it and an area that's below it. So when I look at this area, if you saw the volume from the top, right, and revolved it, you could see what one radius would be. Top, subtract, bottom. And the same thing here, top, subtract, bottom. Here's the truth, though. Let's look at it again. Oh, what was that? That if I want to find the full radius every time, you are actually going to go top, subtract, bottom, and you can treat it as one circle. So when I go top, subtract, bottom, what expression describes it again? Negative x squared plus 4. Come back here. Along the x-axis, we're going to treat it as one solid disk. What's the template for that? Pi r squared dx. And then what goes inside is negative x squared plus 4. And what are the bounds again? From -2 to +2. All right, use your calculator. So for the first answer, revolving it around the x-axis, I get the answer 107.233. Now let's look. What's going to happen when you revolve it around a different line? So what's going to happen when you revolve it around y equals 10? Let's go back to the front page again. So y equals 10 is going to be, y equals 10 is going to be above our area. Above. See that? For y equals 10. This is definitely going to create a washer. What's going to describe the big radius? Well, how to figure that out is you start at the line that you're rotating around and you draw a vertical line to the outer edge and go, what is that outer edge of that big radius? What's the outer edge? What describes the outer edge is the parabola. And then I go top. What number is the top? Subtract the bottom. So let's do that right now. So go back. We're going to go top, subtract bottom. Big radius. So our template there's our template where we have big radius and small radius. We just said the big radius is 10. Subtract, I'm going to use parentheses, and you put in negative x squared plus 4. What's going to describe the small radius? When you go back to the front page, what describes the front edge of the area for the smaller radius? So it's going to be 10 subtract, and the line, which was, so if I go back here, the front edge is the line, so it's 10 subtract, and the line was negative 2x plus 4. So go back. Negative 2x plus 4. Mm-hmm.
Shouldn't the first part say x squared minus 2x? Because that negative x squared plus 4 is different. It's not the actual quadratic.
It isn't, is it? I'm using the wrong quadratic, aren't I? Which quadratic should I use that describes the outer edge? X squared minus 2x. Let me write it over again with the right quadratic. Here we go. That's okay. So, it's okay. So, why is negative x squared not the right quadratic? So, that one described, right, the side when we went top, subtract, bottom of the area, but not the actual quadratic equation. So, let's do it correctly from the beginning again. So, pi, negative 2 to positive 2. The big radius, we said, was 10 subtract. And again, what was that parabola? Was x squared minus 2x. Is that right?
Yes.
And then we're going to square it. Now, what's going to describe the shorter radius? Is 10 subtract, this one was right, negative 2x plus 4 squared. All right, use your calculator. The big radius and the small radius. Shh. Everyone should be practicing using their calculator here. So, we're going to start with pi. And then we're going to integrate, again, from -2 to +2. I'm going to start with a parentheses, and then another parentheses. So I'm going to start with 2 parentheses. Inside this will be 10, subtract, another parentheses, and now the parabola goes in, which is x squared, subtract 2x. We're going to close it. We're going to close again and square. Subtract. See how I thought through the parentheses there? Again, I'm going to open up another parentheses. Again, I'm going to go 10 subtract. Again, another parentheses. And now it's going to be the line, which was -2x plus 4. We're going to close it. We're going to close it again and square it. And now it's dx. So I get that typing using your calculator, you need to be aware of the detail of the parentheses to be able to type it in correctly. If you want it to be easier to type in, you would simplify it first in terms of what to get the big radius and the small radius. All right, what's the volume now? It's 509.357. All right, I have one more to do. So y equals -5. Can you find the volume by rotating around that line? So together, can we go back to the front page again? Where is y equals -5? Now it's below, correct? Come back to it later, all right? Now, how does that change the big radius and the small radius? Start from what the line is that you're rotating around. Now, when you take it from there, draw a vertical line to the outer edge. What describes the outer edge now? That outer edge now is the line, and we go top, subtract, bottom. That's the big radius. Top, subtract, bottom. So let's come back here. So maybe it's better if I simplify it. It'd be easier with your calculator. So we just said the top is the line, which is -2x plus 4. And I said top, subtract, bottom. And if I go top, not -10, what is it? -5. When I go top, subtract, bottom, what is the big radius simplified to? So when you subtract -5, that's subtract -5, what's happening there when you subtract a negative? So it's really 4 plus 5, which is, yeah, you're subtracting a negative, which means you're adding. So it's really 4 plus 5, which is 9. Maybe it's easier to simplify before we put it in our calculator. How about the little radius? Now, if you go back to your area for the little radius, I want you to notice that if you draw a vertical line to the front edge, so the vertical line to the front edge, what describes the front edge of the radius? The parabola. And again, it's top, subtract, bottom. So let's go back again. But this time we're going to use, and I'm going to use the correct quadratic. So, x squared minus 2x subtract top subtract bottom. Again, I'm going to simplify it to make it easier on my calculator. That's x squared minus 2x. When you subtract a negative, it is adding 5. Now I'm ready. I have the big radius. I have the small radius. I'm going to remind you of the template again. It's pi. We integrate. In this case, we're integrating from -2 to +2. We start with the big radius, which is -2x plus 9 squared minus the small circle, which is x squared minus 2x plus 5 squared dx. All right, put this in your calculator and get the volume. Does anyone have a calculator at your desk? Oh, good. Can you type it in, please?
It's 495.953.
Awesome. I'm going to type it in, too. I believe you, though. So again, I'm going to type that in. I'm going to again start with 2 parentheses. And then I'm going to type in -2x plus 9, and I'm going to square it. Subtract, again a parentheses, x squared, subtract 2x. I'll show you what I typed in after I type it in. Plus 5, close it, square it, and then close the whole thing dx. So this is what it looks like in my calculator. Which is exactly what you told me, right? Awesome. So I'm going to write that answer down. 495.952. It's okay to truncate. You don't have to use rounding rules. Just stop. 3 numbers, done. When you're ready, read question number 5. We're just going to go, and I'm going to trust you that you're not going to talk over me while the video is happening, because that's rude. And you're going to do your best, because you are in calculus, and you are university bound, right? And that you have that ability to put your best effort to listen and prepare yourself to actually pass a test on Thursday. When you're done, I'm asking you to read question number 5 and put your best effort in. I'm leaving this up because some are still typing using their calculator. And if you're finding you're not getting the same answer as me, then take a break for a moment, come back to it later sometime, and try to type it in again, or find a time where I can help you type it in to make sure it matches, okay? All right, here's number 5. It says, a region is bounded by x equals -5 and x equals y squared minus 2y subtract 8. It says sketch and shade the region. So I want to sketch this. Obviously, what would be a good thing to find that we don't know are the points of intersections. Let's do that. So obviously, this is not a function. It's okay. Both are already set up nicely, meaning they both say x equals, right? So that means I can make them equal to each other and then solve it. So when I do that, that's what it looks like. To solve it, I'm going to add 5 to both sides. -8 plus 5 is -3. And then I'm going to solve it by factoring. Do you know how to factor that without drawing a diamond? What 2 numbers multiply to -3 and add to -2? Those are not my answers. Those are my factors. So from the first factor, what answer do you get? You get +3. And from the second factor you get, so I still need to know, and I'll put them in an order will make better sense to you. I need to know what x equals, but it's really simple. And I'll tell you why. So y is 3 and y is -1. Believe it or not, what you just found also for your integration are your bounds. We're going to be using y values for our bounds for this setup. The x, what does x equal always, no matter what number you plug in? So for both of these, x is going to equal what? So one point is -5 and 3, and the other is -5 and -1. All right, we're going to sketch this. So -5 and 3, -5 and -1. So we have our vertical line, right, that goes through that? And we have 2 points. You know what shape y squared minus 2y minus 8 is going to be? It's going to be a sideways parabola. What do we need to know that we don't know yet for that parabola is the vertex. We can find the vertex with the same formula, which is -b over 2a. In this equation, what number represents the b? -2, and the a is +1. When I simplify it, a negative times a negative, it's going to be +2 divided by 2, which is 1. That's the y coordinate of the vertex, because it's a sideways parabola, okay? But we still need to find what? So we take the y value, and what do? As I plug it back in, and could you tell me the x value of the vertex? This is 1, take away 10. That would be, so where is the vertex? Oh, make sure I put the right coordinate first. -9, and then what? +1. Can you find -9 and +1 on your graph? And then can you draw a sideways parabola and shade in the area that's bounded? So I'm going to go back to my graph. I found -9 and +1. So here's your graph again, right? So this is 5, 6, 7, 8, 9, and +1. And now you can draw your sideways parabola, correct? What's the area trapped or bounded by the parabola? And the line is right here. So it says sketch and shade the region. What does step B ask you to do? So I'll give you a moment to finish the sketch. Do part B. Set it up and then use your calculator. So, do you notice this is now right subtract left for the area? Because it's sideways. So we're not going to use the x coordinates. What's going to give us our bounds is the y coordinates. Notice we're not doing the silliness of pi r squared. It's not a volume, right? It's just area. So no pi. The bounds are -1, 2, 3. What's on the right compared to the left? The right is the vertical line, which is -5, and you subtract, use parentheses, and what's on the left is y squared minus 2y, subtract 8. No squaring or nothing, just right, subtract left, and that's dy. Now, we're actually going to find this two ways. We're going to do it by hand, and we're going to use our calculator. So if I did this by hand, no calculator, what I do is simplify this. I'd have -y squared I'd have a negative times a negative, which would make it plus 2y. And negative 5, subtract negative 8. When you subtract a negative, you're adding. It's negative 5 plus 8. That would be 3. How would I integrate that? What would you do to the exponent? You would add 1 to the exponent and divide. The next one, add 1 to the exponent, which is y squared. What happens when you go 2 divided by 2? They cross out. And then 3, what is it? Just 3 what? Y. And I'm integrating from where to where? Negative 1 to 3. What do I plug in first? You plug in the top, the upper bound, which is 3. So you first plug in 3. And whatever answer that is, you subtract, and then what number do you plug in? What's the bottom bound? So then we plug in negative 1. Now, that's your exact answer. I'll use my calculator. Could you type in what you did at the very beginning, the very first setup? Type it in and then get the answer fully simplified using your calculator. So I'm going to write and put in the integration again from negative 1 to positive 3. I'm going to start with the parentheses. I'm going to go negative 5, subtract parentheses. I'm actually going to use the letter y. So I'm going to go y squared. Remember, you have the full keyboard on the bottom. Negative 2y. Or subtract 2y, subtract 8. Make sure you put dy. For this, I'm going to put in the exact answer. So that's what mine looks like when I typed it in. Using y, using the keyboard on the bottom of your calculator. And the exact answer is 32 over 3. And I'm avoiding the decimal if I have an exact fraction. All right, read part C. And the good news is, of course, is that because we're doing a video, that when you study for the next test and the next one, the part 1 and 2, that you can press pause and so on anytime you need to make sure you know what you're doing. Part C. What does part C ask? It says, take that area and find the what? Volume by using rectangles perpendicular to the y-axis. And the height is 3 times the base. So the height is equal to 3 times the base. Now, when I look at this area, rectangles that are sideways, the base is going to be right, subtract, left. That's what this is here in the parentheses, right? So the base is going to be right, subtract, left. So I'm actually going to do the simplified one. The negative y squared plus 2y plus 3. So do you remember how we got negative y squared plus 2y plus 3? Is we went right, subtract, left, and simplified it. Now, why am I writing on the height and the base? Because the area of a rectangle are those two things. So what's the base of the rectangle? Negative y squared plus 2y plus 3. And what's the height of that rectangle? Is 3 times the base. And we just said the base was negative y squared plus 2y plus 3. So do you see how I had the base? and then 3 times the base. I'm integrating again from -1 to 3, and this is dy. Use your calculator. So again, integrating. So I'll type it in if you can't see it, and then I'll move my calculator over if you need me to. So I'm integrating again from -1 to 3. I'm going to start with 2 parentheses. In the first one, I'm going to type in -y squared plus 2y plus 3, close it. A second parentheses. So this is what mine looks like as an exact answer. Did you type in? See if you get the answer 512 over 5. Be careful, right? Knowing how to use your calculator is a skill. So you need to take your time and know the detail of your calculator. If you're done part C, look at part D. Part D says, what would happen if you revolved it around x equals -11? Can you go back to your graph? Where's -11? Can you see where it would be? There's -11. If you revolve it around -11, it will be a washer. You'll have a big radius and a small radius. To find the big radius, start at your line of rotation, draw a horizontal line that goes through to the outer edge. What's on the outer edge? The outer edge is -5. What's on the left edge? Right subtract left. -5 and -11. Just use your common sense. What is that width from -11 to -5? 6. That's it. So the big radius is -5 subtract -11, or just use your common sense, and the big radius is 6. How do I find the small radius? So when you start with the line of rotation, and I go to the front edge, what describes the front edge of the little radius? That is the sideways parabola, right? So right subtract left. That means we're going to start with y squared, subtract 2y, subtract 8, that's on the right. And what are you going to subtract? Is -11. Simplify it so it's easier to set up and then put in your calculator. This is y squared minus 2y, -8, subtract -11. When you subtract a negative, you're adding. -8 plus 11. Now, what's the setup going to look like? We're revolving, right? So what shape is that? A circle. There's 2 radiuses. So what are we going to start with? Pi. I'm integrating from -1 to, what's the big radius? And square it. What's the small radius? Y squared minus 2y plus 3 and square it. Pi r squared, subtract pi r squared. Now use your calculator. What is the volume? practice typing it in. Practice detail with your calculator. Parentheses, take your time, use your calculator, and find the volume. I'll show you what my calculator looks like, what I typed in a second. Did you type it in correctly? Did you get 294.890? And again, you just need to truncate. You don't have to use rounding rules. So you just go 3 numbers after the decimal and be done. When you're ready, turn the page. So far, we've done 5 questions. 1 hour and 2 minutes. Yeah. Turn the page. Number 6. So number 6, it gives you the first derivative, 3ax squared plus 2bx plus d. It tells you f at 0 equals 4 and to find f at 1. So this is a starting value question. What value does it start at? 4. And then we're going to integrate. And we're integrating from the x value we started with, which is 0, to what I'm looking for, which is positive 1. And we're going to plug this in, right? Now the challenge is that I already have A's, B's, and D's, right? Now, how can I help myself out here just a little bit? This is the start. So it's 3ax squared plus 2bx plus d. That's what it would look like to find f at 1. In fact, the information you're given, you don't have enough information to go further than that. We don't have the information to know what A, B, and D equal. We have a point. But even when I integrate this, so if I integrate this, which means add 1 and divide by 3, let's just try it for fun. Add 1 to the exponent and divide it by 2, and then this would just be dx. That's what the equation would look like. You would have candy involved. Is it off the screen? All right, there it is on the screen. So, simple anti-power rule. Add 1 to the exponent and divide. I could clean it up a bit. The 3's cross out. The 2's cross out. Recognize it's dx, not like it's the derivative with respect to x, but just the letter d with x. And then the big candy. It does tell me that when you plug in 0, what does the answer would be? So if I plug in 0, I actually know what c equals, which is 4. So when I substitute in here, what could I do? Is I can do what? what's at the end here? Is 4. But that's all the information I'm given. I'm not able to actually solve for A, B, and D with anything else. But by integrating, I can solve for the constant. And then this is the setup for a starting value problem. So the starting value was 4. And then we're integrating from 0 to 1 to see if it increased or decreased from 4 to see what the value at f at 1 would be. All right, read number 7. Number 7. A plane is flying how far above the ocean? We're going to annotate it a bit. A flare gun is fired upward with an initial speed of 32 feet per second. How long, this is the question, how long will it take the flare to hit the water? That's my big question. How long means I'm looking for time, knowing that gravity pulls the flare down at an acceleration of negative 32 feet per second squared. All right, let's start with acceleration. What's a equation for acceleration? It gave it to me. It's negative 32. How do I find the velocity if I know the acceleration? What's the integration of negative 32? It would just be negative 32t plus what? The constant. Hey, I circled a number. What's the initial speed? And I know it's the absolute value velocity, but if they're both positive, they're equal. What's the initial speed? 32. So if I plug in 0 for t, initial means when t is 0, right? What is the velocity equal at 0, which is 32. So what does that tell me for what c equals then when I solve it? Plug in 0 and c would equal 32. So now we have an equation for the velocity, negative 32t plus 32. The question is, how long will it take for the flare to hit the water? Now, to hit the water is a position equation. So I'm going to use the letter S for position. How do I find the position if I'm given the velocity? What do I need to do? Integrate. How do I integrate this? Add 1 to the exponent and I get t squared. Then I divide. What's negative 32 divided by 2? What number would be in front? Negative 16. Again, how would I integrate 32? That would be 32t and then the candy, right? The very first number I circled, what is c equal? What's the initial height of the flare? 128. So what is c equal in the second one is 128. Then the question is, how long till it hits the water? What would this position be if it hit the water? 0. Now we need to solve. Is it off the thing there? All right, that's the equation we're going to solve. Now, believe it or not, I know this looks difficult to factor because the numbers are so large, but I can divide everything by negative 16, and now it's going to look a lot better. So there's a common factor to simplify the quadratic equation. So 0 divided by negative 16 is 0. Negative 16 divided by negative 16 is positive t squared. 32 divided by negative 16 is negative. And then this is the tough one. What would your assumption be? It's not 4. 16 times 4 is 64. Double it. 8. And it'd be a negative 8. Well, now it's a really easy quadratic, isn't it? What two numbers multiply to negative 8? And the same numbers add to 2? That would be negative 4 and positive 2. One answer is positive 4. The other answer is negative 2. Why am I crossing that out? We don't want negative time. So the question is, how long will it take the flare to hit the water? So it will take 4 seconds for the flare to hit the water. Oh, I like that energy. Sing it out. So it will take 4 seconds for the flare to hit the water. Perfect timing. So, Mr. G. Math over.